So it's falling a distance h. So if I say initial kinetic energy plus initial potential energy is equal to final kinetic energy plus final potential energy. Now I have a problem. What do I want to pick as my zero for potential energy? Should I pick where it starts? Should I pick the floor and go up? Does it matter? It won't matter. What would you prefer? Which? The first. Suppose that I pick here as my zero of potential energy. Do I have to worry about the potential energy of this guy? Why not? Yeah, it won't change. At least I'm only going to worry about the motion before it crashes into the pulley. Okay, after that, bets are off. So I only have to worry about the change in the potential energy of this one. So let me call this the zero of potential energy. And it starts from rest. So what's the initial kinetic energy? 0. And the initial potential energy? 0. That must be equal to the final, the final kinetic energy. What's the final kinetic energy? Let's see, 1/2. Both masses are moving the same, at the same speed, not the same velocity, but at the same speed. And what is the change in potential energy? What's the final potential energy? Okay, positive or negative? Yeah. Yeah, so she's saying, why isn't U naught mgh? Because it's starting up and it's falling a distance h. Blame him, he chose. Well, okay, I made it up. I'm going to do it two ways. I'm going to say, suppose that I define this to be the zero of potential energy. Then if I'm down here, am I at positive or negative potential energy? I'm below 0, right? So I'm at negative. So if I do it this way, over here I have to add minus big M GH. That's if I define the zero of potential energy to be here. Now let's go back. Okay, so maybe I finish solving this, and I get mgh is equal to 1/2 m plus m v final squared. So I can solve for v final. V final squared is equal to 2mgh over m plus m, and take the square root. So that worked. Alternatively, I could define, let's say, by the end, it's fallen a distance h. So let me call the floor 0, and I go up h. Do you get it? Anybody need that worked out? We're good? Okay. So the point about potential energy is the change in the kinetic energy is related to the change in potential energy. It doesn't care what you pick as an origin as long as you stay consistent within the problem. Okay, so you can use that definition to your advantage.